Let's say we have a function f of x equals 2x squared minus 5x, and if we use power rule to find its derivative, we will get 4x minus 5 as the answer. But in this video, we will try to find the derivative by using the first principle of derivatives, and here's the formula for it. In case you are wondering how the formula is derived, you may check out the video above or in the description to learn more about it. Now, let's start solving this example. The first thing we want to do here is to plug in f of x plus h and f of x into the formula. For f of x plus h, it actually means that when we have a function f of x and we want to plug in x plus h into it, that's how we'll get the f of x plus h. In this case, our function f of x is equal to 2x squared minus 5x. And notice that we have two variable x inside of it. When we want to plug in something into the function, we substitute it into the variable x. Therefore, by plugging in x plus h into variable x inside of the function, we get 2 multiplied by x plus h squared, minus 5 multiplied by x plus h. And that's what we call it as the function f of x plus h. We can now plug this expression back into our formula, and it represents this part of the formula. Now, for this f of x, it simply represents our function, which is 2x squared minus 5x, so we just copy this expression back into the formula. But what I would like to mention here is that we enclose the expression in brackets. It is important to use brackets because in this case, we treat the expression 2x squared minus 5x as a single unit representing the function f of x. And we have finished plugging f of x plus h and f of x into the formula. Now, the main thing we want to do here is to get rid of the h in the denominator, because if we try to solve this limit using direct substitution, we will get 0 in the denominator, which is what we want to avoid. In order to get rid of the h in the denominator, we want to simplify the numerator, which involves expanding terms, combining like terms, and factorization. Let's begin by expanding the terms in the numerator, and we start with this x plus h squared. We know that x plus h squared is also equal to x plus h multiplied by x plus h. To expand this, we start by multiplying x in the first bracket and x in the second bracket together, in which we get x squared. Now, we multiply x with h, and we get hx. Multiplying h and x, we get another hx. Lastly, multiplying h with h together, we get h squared. Since we have two sets of hx, we add them together to become 2hx. And we have now finished expanding the x plus h squared. We can plug it back into the formula. Then, we can expand this expression by multiplying 2 with every term inside the brackets. Starting with 2 multiplied by x squared, we get 2x squared. Multiplying 2 with 2hx, we get 4hx. And multiplying 2 with h squared, we get 2h squared. Now that we have finished expanding the expression, we plug this back into the formula. Now, we just repeat the same process for this minus 5 multiplied by x plus h. Multiplying negative 5 with x, we get negative 5x. And multiplying negative 5 with h, we get negative 5h. We can now plug this back into our formula. The same process applies to this expression as well. By introducing a negative into 2x squared, we get negative 2x squared. And introducing a negative into negative 5x, we get positive 5x. Just to clarify, as we have two negative signs, one outside and one inside the brackets, this is why we end up with a positive sign. It's a common careless mistake where we forget to change the sign to positive, which we want to avoid. And finally, we have finished expanding all the terms. The next thing we want to do is to combine the like terms together. Since we have 2x squared and negative 2x squared, when we combine them by adding, they actually cancel each other out and result in 0, so we can simply cancel them out. The same concept applies to these terms as well. As we have negative 5x and positive 5x, we can just cancel them out. Now, we can factorize the terms in the numerator since they share a common factor, which is h. Notice that h appears in each term in the numerator. By factorizing it, we get h multiplied by 4x plus 2h minus 5. and we plug it back into the equation. Notice that this fraction can now be simplified, as we have h in the numerator as well as in the denominator, so we can simply cancel them out. We can now solve this limit by using direct substitution. Since we have a limit as h approaches 0, by using direct substitution, we simply plug in 0 into variable h. By multiplying 2 with 0, we will just end up getting 0, so we can cancel it out. Finally, we end up with 4x minus 5, and it is the derivative of the function f of x, which is exactly the same as what we obtained earlier by using the power rule. That's how we find the derivative of a polynomial function using the first principle method. Hope you guys enjoy this video and find it helpful. Thanks for watching.